Matter cannot undergo any of the physical and chemical changes we have learned about without a corresponding change in energy. If matter were to change without energy, we will be talking about magic. And then the next question would be, what is energy? Because without energy, matter cannot change by itself. Energy is simply defined as the capacity to do work. For example, if I have not eaten for the last 2 weeks, teaching this class by recording the video would be almost impossible. That is the everyday usage of the word work. But in scientific parlance, work is the result of a force that is acting on an object and moving the object through a certain distance. For example, take a look at this guy. He is applying some force to push this load through a certain distance. We would simply say that he is working. Work is being done on the load. So energy makes work possible, which means we need to know a little more about energy since it is so important to transformation of matter. Well, the first thing we want to know about energy is that there are two types of energy. There is the one that is called the potential energy, which is defined as the energy due to the position or the composition of an object. But I would define it in a very simple way as stored energy. That is energy that is not yet being used, but is present in the substance. For example, if you buy a battery, before you connect it to your cell phone, the energy stored in that battery is just potential energy. And I also always tell my students about this. Many students believe that chemistry is very difficult, but you would not be taking this class if you do not have the potential to pass it. You have already passed several courses before you get to this point. That means you have the potential. All you need is to unleash that potential energy. The second type of energy is called kinetic energy. Kinetic energy is due to the motion of an object. Any object that is moving is expending kinetic energy. The total energy of an object is the sum of its potential and kinetic energy. There is a fundamental law of nature that governs energy. Energy is neither created nor destroyed. Now, what does that mean? It simply means that the total energy at the beginning of anything in nature will be equal to the total energy at the end of that thing. Let me give you a very simple demonstration here from the picture you see on your screen. Look at this object. It is on the edge of a building, which means it is unstable. And when it is unstable, it is said to possess high potential energy of tipping over. If it tips over, it will begin to move, which means some of its potential energy will be converted to kinetic energy. When it lands on the ground and it is now more stable, it can no longer easily tip over. It now has very low potential energy, and by crashing on the floor, it would expend some heat. How is this demonstration applicable to the law of conservation of energy. The law of conservation of energy will be applicable here if you know the high potential energy at the beginning will be exactly equal to the sum of the kinetic energy of the object plus the low potential energy of the object plus the heat that was released. In a nutshell, the total energy at the end will be equal to the total energy in the beginning. Although energy can neither be created nor destroyed, energy can be transformed from one form to another. For example, chemical energy can be transformed into electrical energy. That is how our batteries, that is how they work. There are three common units for energy. The most common unit is the SI unit of energy called the joules. That is the SI unit. But there is an old unit that is still used up till now that is called calorie. But there are two types of calories. There is one that is called nutritional calorie and there is another one called conventional calorie. The relationship between the two calories is that one nutritional calorie will be equal to 1000 conventional calories. Or you may see this relationship written as 1 nutritional calorie is equal to 1 kilo conventional calorie, because 1000 literally means kilo. The difference between the two when they are written down is that the nutritional calorie is usually written as uppercase C, while the conventional calorie is written as lowercase c. Let us quickly look at a very simple question on how to convert from one energy unit to another. In this question, we have the complete combustion of a wooden match, which produces 512 conventional calories of heat. The question itself is that we should convert this to kilojoules. So how do we go about doing this? We can convert the conventional calorie to joules and then convert to kilojoules. Let us take a look at the relationship. From this table, you can see that one conventional calorie is equal to 4.184 joules. So, if we have 512 calories, we can use the relationship that 1 calorie is 4.184 joules as our conversion factor. So our conversion factor is that 1 calorie is 4.184 joules. Calories will cancel out. Then we can convert to kilojoules. We know that kilo literally means 1000. So 1000 joules will be 1 kilojoules. Joules can cancel out. So we now have the unit we want, which is kilojoules, and the calculator will finish the rest for us. My calculator gives me 2.142208 kilojoules, which we can then round to 3 significant figures, which would be 2.14 kilojoules.